this can be reasoned out. We could use the equations, we could use formulas, we could integrate, use initial conditions, all that kind of stuff, right? That's beating the gnat with a sledgehammer. It takes much more work. You can do this in your head, okay? And, you know, and this is a velocity v sub y, changes by negative 40 meters per second. How can I make that statement? Simply understand what acceleration means. It's the rate of change of velocity with respect to time. So if we multiply the constant acceleration by whatever time, we're going to get the change in velocity, right? It's going to be negative 40 centimeters per second. And I don't have to write all the numbers. You can fill in these blanks. Okay? If I keep filling in all the blanks, we'll never get anything done. Right? So if you can't fill in a blank, I mean, if you've got a question about how we get from here to here, email me saying, hey, you said this and you said this. Where'd that come from? I'll answer you. Okay? Fair enough? Okay, so velocity will be this. Now, this means average velocity. For the 4 seconds is what? How are you going to get it? Quick. Not quick? Starts at 10, ends up at negative 40. What's the average?
Negative 20.
Okay. Okay. Not quite.
We do 17? Sorry, 15.
Negative 15, yes. How do you average two numbers? Add them and divide by 2. Negative 10 and negative 40 is negative 30. Half of that is negative 15, right? Okay? Now you got to think with the definitions, because this is just definitions of average. Now why can we average these two to get the average velocity? You can't always do that. You can do that because velocity versus time is linear. You're averaging two quantities that change along a straight line, that change linearly. So the middle point value is the average of the initial and final. And we said this, okay? So you might go back and try to dig it out someplace, but if you understand it right now, you don't need to do that, okay? So, y changes by negative 60 meters, right? No formulas, no magic, nothing you don't totally understand or don't need to totally understand, okay? With uniform acceleration, you can do all these things.